Hi everyone, and welcome back to Mr. Gard's maths class. Today we're going to be looking at index laws and particularly multiplying and dividing powers. There are a number of index laws and today we're going to look at two of them. You might be able to see them already as golden rules at the bottom of the screen. Firstly, we must remember a couple of key points. If we look to the left of the screen, you can see that section where it says multiplying powers. Now, this only works when the base numbers are the same. So that's worth keeping in mind. So in this case, we look at sort of the x squared is the same as saying x multiplied by x in this little bit here. If you look below, it says x cubed, or x to the power of 3. Remember, that means x times x times x. It doesn't mean 3x. That would be x plus x plus x. So just keep that in mind. So if I was to show 5 squared, that in fact means 5 multiplied by 5, which we know equals 25. Likewise, 5 cubed is 5 times 5 times 5, which equals 125. If we look at the question below that, where we say 5 squared, or 5 to the power of 2, multiplied by 5 to the power of 3, let's think about what that means. It means 5 multiplied by 5 multiplied by 5 multiplied by 5 multiplied by 5. The color coding shows you where those 5s are coming from. Now, if we were to multiply that out, it will equal 3,125. Another way we could write 5 times 5 times 5 times 5 times 5 is 5 to the power of 5, because there are 5 of them. Now, a little golden rule is going to start showing up. 5 to the power of 2 multiplied by 5 to the power of 3, if we look at the indexes, we can add them together. And they are how we can get that 5 to the power of 5, because there are 2 of them here and 3 of them here, and so there's a total of 5 of them. It is worth reiterating that this does only work when the base numbers are the same. So it wouldn't work if I said 3 squared times 4 squared doesn't equal something like 3.5 to the power of 4. That one. So if we look now below at the golden rule, often for some reason we like to write a as the base number and m and n as the powers. So our golden rule is a to the power of m plus n. So we can add those two powers together and we get the new answer. It is definitely worth writing that down, and once you do a few questions you will see that that works every time. But again, it only works when the base number is the same for each term. If we move across now and look at dividing powers, bearing in mind that's the opposite to multiplying powers. In the first case, I have x to the power of 3 divided by x to the power of 2. Now I can rewrite this as I have over here in purple. It's x times x times x on the top line, or on the numerator, and x times x as the denominator. Now, according to our rules of division and fractions, we can simplify. So where x divided by x, that equals 1. Anything divided by itself is 1. So I'm just going to write a 1. And we know anything multiplied by 1 is also just itself. Now I can also cancel out these two x's. And that is also 1. So if I was to now rewrite that, on the top line I have 1 multiplied by 1 multiplied by x, which is just x. And on the denominator I have 1 times 1, which is 1. So my answer is x divided by 1, which is simply x. Now it's also worth remembering that x actually does have a power as well. Its power is 1. We don't often write x to the power of 1, we just write it as x because it's just one of them. I'm going to now do the example below, and I've probably made this a little bit tricky for myself, but I've gone 3 to the power of 6 divided by 3 to the power of 4. So that simply means 3 times 3 times 3 6 times divided by 3 times 3, 4 of them. So now, according to our rule from before, we can simplify because 3 divided by 3 is 1. 3 divided by 3 is 1. And we're left with 3 squared on the top line. Obviously that can be 9 divided by 1, which equals 3 squared. Now according to our indexes from earlier, you might see a bit of a pattern. We had 6 and 4, and we ended up with 2. You might be able to tell what our golden rule is based on what we learnt when we were multiplying our powers. It is, of course, a to the power of m minus n. And that's going to work anytime we divide powers and the base numbers are matching. It's important to remember your rules with fractions and dividing numbers, but ultimately if you remember these two golden rules, you shouldn't have too many problems. I just find that generally people make a mistake by trying to combine base numbers. But in this case you can't. Hopefully that helps you, and good luck for the future questions.